Hey, what's up, everybody? Welcome to episode 9 of the Microsoft AZ-800 course. Now, as you guys can see, today's video is titled Networking on Hyper-V Host Servers. So it's safe to say that today's video is all about networking on Hyper-V. Now, with that said, let's have a look at the topics we're going to be talking about today. So we're obviously going to be talking about the different types of Hyper-V networks you get. We'll mention that in just a moment to you guys. We're going to give you guys a short demo as to how to go and create those networks, which is actually more known as Hyper-V switches. More on that in a moment. And then we'll also show you guys how to go and link those switches, which we're going to be creating. So we're first going to discuss them, then we're going to create them, and then we're going to link them to your virtual machines. And then lastly, we're going to be talking about best practices for configuring Hyper-V virtual networks. This is not stuff that's set in stone. It's purely stuff that you need to keep in the back of your mind when you're working with Hyper-V virtual networks. Now, without any further ado, let's get right down to business. Let's look at our first topic here being types of Hyper-V networks. Now, when it comes to the different types of Hyper-V virtual networks you get, there's three kinds. The first one is a private network or a private switch. Second one being an internal network, and the last one here being an external network. Now, all three of these are very important for the exam. Microsoft has the tendency to go and ask these a lot in the exam, and they want to see if you understand what they are and what the differences are, and they like to favor the one that's external especially. So they want to see if you know the difference between these, their restrictions, their pros, their cons, that kind of situation. So I think in short, what's the difference between these? So if you were to go and create yourself a Hyper-V switch in the Hyper-V manager, depending on which one of these three you go and choose, that will determine the restrictions that network will have and to what extent your virtual machines can communicate amongst one another and other components amongst things. So if I were to go and choose a private switch, they can only communicate with one another. An internal switch, they can communicate with one another as well as the host they're being hosted on. And then the last one being external, they can communicate with one another, the host, any other host, any virtual machine on any other host, and the internet. So in other words, that last one is basically full access, no restrictions whatsoever. So let's put that into a picture for you guys. So you can imagine those two big blue blocks being two physical hosts. This could be a desktop or a laptop, could be a server, that's besides the point. And on both of these two hosts, I'm running two virtual machines on each. Now, I want you guys to focus on the one on the left, host 1, more specifically virtual machine 1 on host 1. So if I were to go and choose the private switch, and if I were to connect that private switch to virtual machine 1 and all my other components, virtual machine 1 would only be able to communicate to other virtual machines on host 1. So whatever host virtual machine 1 is running on, it will only be able to communicate with other virtual machines on that specific host. Nothing else. So it's very restrictive in that sense. Very few people actually go and use a private switch. It's normally only used for testing purposes or, well, ironically, classroom purposes, which is what we're doing right now. Now, looking at the second one that we've got there on our list, internal. It's a little bit less restrictive, so I suppose you can think of this as those lockdown levels that most countries has when it comes to COVID-19. So private will probably be one of the most restrictive lockdown levels. Internal is less restrictive, so you can go and do more things. And external is even less restrictive, probably the least out of the lot. Now internal, besides the virtual machine 1 being able to communicate with other virtual machines on that host, it also allows virtual machine 1 to communicate with the host on which it's being hosted. But with both internal and private, the traffic does never actually leave that host, being host 1 in this case. So in that case, I don't actually need a physical network card because the traffic will never actually physically leave that host. So if it's a private, I only need to be able to communicate with other virtual machines. If it's internal, it's only going to communicate with the host at most. And that situation, it's still not going to actually leave that host. Now, looking at the last one being external, you can see virtual machine 1 specifically. I'm only focusing this on virtual machine 1, otherwise there's going to be too many lines on my drawing here. Virtual machine 1 will be able to communicate with anything for that matter. any other virtual machine on that same host, any virtual machine on any other host for that matter, or just plain out the internet. So no restrictions for the most part. So if I were to give you a virtual machine that's got, let's say, an internal virtual switch on it, and I ask you, why is this virtual machine unable to connect to the internet? What could be a possible problem here? Your answer is going to be something along the lines of, it is because you're using an internal switch, sir, and you need to use an external switch. So with an external switch, as you guys can clearly see, the traffic is now going to be able to leave host 1. And since it needs to be able to physically leave host 1, that virtual machine needs some form of hardware in the sense of a network card. Now, as you guys know, virtual machines don't have their own hardware. So it's going to share the network card of host 1. So when we go and create our network cards now, or these virtual switches, you guys are going to see that in a moment. As soon as you choose an external switch, it actually allows you to choose which network card in your host you would like to go and associate the external switch with. But if you go and choose private or internal switches, there's no such option because traffic, well, never leaves the host. So let's show you guys how we actually do this practically. Let's move on to our next topic, which is creating Hyper-V switches. That's basically the Hyper-V networks we just spoke of. So I'm going to switch over to Hyper-V Manager now. And there we are. So for time being, please ignore the virtual machines on the right hand side. So when you find yourself in your Hyper-V Manager, whether it be on a client computer like Windows 10, whether it be on a server like Server 2019, potato, either way, what you're going to want to go and do is way here on the right, it says Virtual Switch Manager. That is one of the ways you can go about creating yourself a virtual switch. So I'm going to click on that. Opens this little menu. Now normally what you would see is this option which is highlighted that says New Virtual Network Switch. And you'll see this little section here that says Global Network Settings with the little MAC address. Those two things that I'm highlighting right now, that is not something you guys would see by default. If you see something there, or more than mine, that means someone else or yourself went and created a virtual switch somewhere along the line on that host. So if you want to go and make yourself a brand spanking new one, which is what we're going to do, you go here to where it says New Virtual Network Switch. You choose which one you want, private, internal, or external. Those are the three we just discussed. Now I can actually go and choose any one of this and just say Create Virtual Switch, and you'll notice I can still actually swap here between the three, private, internal, and external. The name you give to this virtual switch really does not matter. At the end of the day, it's just to help you and your peers to identify which switch this is and what it's used for. So I've seen Microsoft likes to give it the name of the type of switch it is. So if this is going to be a private network or a private switch, I'll probably call it private network. Something like that. But in reality, you can actually call it whatever you want. So as we've discussed in our previous topic, private only allows them to communicate with one another. So if I connect up between two virtual machines here in the background, they can only communicate to one another, assuming they are on the same switch. Should we choose internal, they can communicate with one another as well as this host which they're being run on. External actually allows that traffic to leave this host, like you guys saw in my little picture. They can communicate with other hosts, virtual machines on other hosts, as well as the outside internet. So if I click on external, you'll see since it's actually going to leave my host, it needs a network card. And since they don't have their own, it's going to use the host's network card. Now I'm doing this currently on a laptop, so in this drop-down list, you're going to notice there's two network cards. On the average machine, you'll most likely just find one. It's most likely just going to be some sort of Ethernet or Realtek adapter, as you're going to probably see here. The only times you're going to find more than one is if you're using a laptop, or if your machine really does have more than one network card because of redundancy, load balance, or anything in that line. So considering I'm running this on a laptop, I need to ask myself first, how am I connecting to the internet? If I'm using wireless, then that's the card I need to choose. Otherwise, my virtual machine is not going to be able to access the outside world like the internet. So if I'm using an Ethernet cable, in other words, a good old-fashioned network or LAN cable, then I need to make sure I choose that for my external switch. Otherwise, the communication for my virtual machines is not going to work properly. So I'm going to go here and choose one of those two. I'm going to click on apply. Okay, it takes about 2 to 5 seconds. I do want to point out that if you go and create an external network switch, or you go and delete an external network switch, it has the tendency to drop your internet connection for a few seconds. So do not be surprised if your internet connection drops. That is normal. So a lot of people tend to freak out when the internet drops, and that's actually very normal. So with that being said, I do not encourage you to go and create an external switch or to go and delete one while your server is running in the middle of production time. So if you're doing this on a server that's hosting other services and you cannot afford for that server to be dropped for a few seconds, then I would not encourage you to do this. Wait until after hours or over a weekend, then you go and do that. Because then if the internet drops for a few seconds, then it's not really going to matter now, is it? So let's go and make one that's maybe private or internal. Doesn't really matter which one I choose. I'm going to choose private since I already gave it a name private. Apply. Okay. Now with private and internal switches, it's not going to make much of a difference because the traffic doesn't actually leave the host. But external, whole different can of worms. Now, since we have shown you guys how to create a Hyper-V switch, that concludes this topic and brings us to our next topic, which is linking those Hyper-V switches to virtual machines. So we've shown you guys how to go and make one, which we did. We made ourselves our own little private switch. And now we're going to go and link that to a virtual machine. So let's go back to Hyper-V for this one. Here we are on Hyper-V again. So this time I'm going to use one of my existing virtual machines here. So let's pretend this Windows 10 machine is the one we want to go and use. So I'm going to go right click on that. Settings. So that's kind of like opening your computer's box, looking inside at the hardware components. And one of the things you would normally be able to see, amongst other things, is your network card. So it might be an internal one on the motherboard, it could be an expansion card, but you could normally see your network card. So if I click on settings, that's like doing the same thing, digitally speaking. So you'll see here it says network adapter. Currently, it's not connected. So in real life, with a physical computer, that would be the same as it just not being plugged into a network cable or it just not being connected to some sort of hotspot of some kind. In other words, a Wi-Fi connection. So if I were to go and connect this to a network, that's the same as plugging a cable into your computer or connecting to a hotspot. Which one you choose, that's the same as which cable do you plug in or which network connect do you connect to wirelessly. Now the one we made is the one called private network. So I'm going to click on that. I'm going to click on apply and OK. And that's that. So now if I want these machines to be on the same network, you just need to give them the same switch. So I need to go to that machine, and just choose the same private switch and they would effectively be on the same network. It's kind of like plugging a bunch of network cables into a switch, plugging one of those cables into my PC and plugging some of the other ones into your PCs. That would normally mean we're on the same network. Digitally speaking, that's kind of sort of the same thing we just did here. We're on the same network, digitally speaking right now. Now what I do want to point out to you guys, let's go back into that Windows 10 machine. You do not need to turn a virtual machine off to be able to switch networks. So just like in real life with a physical laptop, desktop or server, you can plug the network cable out, you can plug one in, or you can swap network cables while the computer or the server is running. And the same can be said with wireless networks. You can disconnect from one, you can reconnect to another, you can switch between wireless networks while the machine is running. The same applies to these virtual switches. You do not need to turn a virtual machine off if it happens to be running to switch between networks. Now what you do need to normally do in most cases is you normally need to go and turn off the virtual machine if you want to go and add an additional network card. Up until a certain point, I think in Server 2016, which is not the course here, this course is more about Server 2019 onwards, but in Server 2016, they added a new benefit which allows you to go and add network cards while the virtual machine is running. That's not normally something you can go and do on a physical machine or a virtual machine. But at least now on virtual machines running on Server 2016 or newer, you can actually go and add network cards as well as change RAM while the virtual machine is running. Very useful if that virtual machine is running something like server and you absolutely cannot afford to turn that machine off. Maybe this is in the middle of production time, or maybe even in the middle of the night. This machine is being very heavily used. Maybe it's like a website server of some kind. We don't know. And if that's the case, and you absolutely cannot afford to turn it down, or you want to drastically reduce downtime, well, you can go and change the RAM now and the network card while it is running. I wouldn't say that's a new benefit in Server 2019 onwards, since this actually came out in Server 2016, But if you did not know, well, now you know. Alright folks, so that concludes linking Hyper-V switches to your virtual machines, which leaves us with our last topic for this video, which is best practices for configuring Hyper-V virtual networks. Alright folks, with respect to configuring virtual networks, best practices typically focus on ensuring that virtual machines are provisioned with adequate bandwidth. You do not want the performance of all virtual machines to be affected if bandwidth-intensive operation, such as a large file copy or website traffic spike, occurs on one virtual machine on the same host. So imagine you've got one host that's hosting multiple virtual machines, and at some point in time, one of those virtual machines suddenly has a huge spike in traffic. This could be because it's hosting a website, something like that. And that is potentially going to influence your other virtual machines on that host. You guys would be wise to invest some time and to invest some money into some of the items I'm going to list for you now. Here is the list of some of the things you guys need to keep in mind with regards to some of the best practices. The first thing on my list is NIC teaming. Now, in case some of you guys don't know what that is, this is when you have more than one network card for a physical or a virtual PC. Obviously, in this case, we're going to be talking about virtual machines though. When you have more than one adapter on a machine, you have what we call redundancy or high availability. So now if one of those two or more cards should fail for whatever reason, the PC or the virtual machine or the physical host, wherever you've got these multiple adapters, will not be inaccessible. And the service it's rendering won't stop. This is especially important on servers since they normally serve some sort of very important role. Most servers render you with some sort of service. It could be that this server is perhaps hosting a website. And if it only has one network card, and God forbid that card should fail, then the website's offline. But if you've got two or more cards on that server and one of these cards fail, at least the website is still operational. Maybe you'll experience a little bit of reduced performance, but it's not offline, which is what is important here. Now, the second thing on the list of best practices is bandwidth management. Bear in mind, though, bandwidth management is not just used for virtual machines, but it's actually used in most medium to large size organizations. In this case, though, we're focusing on virtual machines. So what this does, in case you guys don't know, it allows you to allocate a certain amount of bandwidth to each network adapter. This helps prevent chaos when traffic spikes on one of your virtual machines, because usually then that virtual machine with the spike will hog all the bandwidth to itself, like I said earlier. Now, when you have this bandwidth management in place, it doesn't matter if a specific virtual machine has a spike of some kind. The other virtual machines will be able to carry on exactly like normal, and they will be unaffected by the virtual machine that's hogging all the traffic, or it's trying to hog all the traffic, because each of them has a certain amount of bandwidth allocated to them, obviously. The third item on the list I want to mention to you guys is to use network adapters that support VMQ. Now, if you're wondering what VMQ does, it uses hardware and packet filtering to deliver network traffic directly to a virtual machine. In other words, your network traffic is basically going to skip the host PC where the virtual machine is running. This will obviously improve performance because the packet does not need to be copied from the host operating system to the virtual machine. If you don't configure virtual machines to support VMQ, the host operating system can become a bottleneck when it processes large amounts of network traffic. And then, folks, we have the fourth thing on my list, which is to use network virtualization. Now, this one is a bit complicated for most folks, but it does have some benefits to it, which might make it worth it for most people who are running multiple virtual machines. Network virtualization has an advantage over VLAN. It is not necessary to configure VLANs on all the switches that are connected to the Hyper-V host. You can perform all necessary configurations when you need to isolate servers on the Hyper-V host without needing to involve the network team. If you're hosting large numbers of virtual machines and need to isolate them, well, maybe just use network virtualization rather than VLANs, like we said. Then you don't have to involve the network team. Most companies have a huge IT team, and you are probably somewhere along the grapevine where you only have access to certain things. So if you are perhaps the person tasked with working with virtual machines, you most likely do not have access to the firewall, the switches, the physical switches that is, and things like that. So when it comes to configuring the actual VLANs in the organization, there's a very good chance you do not have access to that. And if you're going to need them, that's going to become a very inconvenient process for you. So what if I can tell you, you don't need the network team? You can achieve the same goal in quite a lot of cases by just using something called network virtualization. Alright folks, that concludes it for this lesson. So if you've learned something, please give the video a like. If you'd like to stay informed of new free training that I upload, remember to hit that subscribe button. And if you'd like to support the channel so I can create more free training content like this, I have a Patreon. You'll be able to find that in the video description down below. Now, speaking of Patreon, I just want to give a special shout out and thank you to the current supporters of the channel. I only created this Patreon about a week or two ago, believe it or not, and I see I actually already have a Patreon. So a special thank you to Todd O'Connor, and I believe that concludes it, guys. So I will see you guys on the next lesson of the Microsoft AZ-800 course. If you love me, let me know. If you don't, then let me.